morning, everyone. In our previous video, we did discuss about solving quadratic problems, and we mentioned about the 4 different methods we can use to solve a quadratic equation. And we looked at 2 of those methods, and today, this morning, we're going to look at the remaining 2 methods, which is factoring, the vertex form, and the graph method. We're going to look at this one and this one. We've done completing the square. We've used the quadratic formula. You remember, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula method. Use the quadratic formula. Today, this morning, we're going to look at factorization, but we're going to use a vertex form. And then briefly we'll discuss about graph method, because mostly you should be concentrating on factoring vertex form. All right, we did mention the last time that a quadratic equation has this form: y equals ax to the power of 2 plus bx plus c, wherein a is not equal to 0. B, C, A, B, C are all numbers. They are all numbers. But this must not be equal to 0. This could be 0, this could be 0. You can have a quadratic equation, this form, ax squared. It's a quadratic equation. You can have it ax squared plus bx, still a quadratic equation. Right. So now we can use this method to plot a graph to solve a quadratic equation graphically. We can use this method. When they give you an equation like this, they will also give you intervals. They can say, okay, take the x values, that is the horizontal values, from -3 to 3. That is, if you now have y equals ax squared, they have told you to use from -3 to 3, so you can start from -3 plus b to the -3 plus c. You find the value, provided this is given. Maybe this could be 1, this could be 2. Then you can just multiply 1 by 3 times 3 minus 3 squared is 9. So 1 times 9, you get 9 here. If this is 2, so 2 times -3, you get -6. And say this is 4. So you compute, and then you find your answer. You evaluate, you get your answer. Right? This is this method. But the one we are going to look at today, which is using the vertex form, you can have a quadratic formula given to you in this form: ax minus h all squared plus k. This is the quadratic formula using the vertex form. You can derive this from this one. I don't want to go into that. It will be a different lesson. You can get this from this. But we're going to have a look at this and solve a problem using this one here. But just to show you how this one works, I'll just rotate this board. illustrate to you. I've solved this already. I just want to explain to you. From minus 7. From minus 7. Here you are looking at, you are given this equation here. They ask you to take values of x from minus 7 to 3, negative 7 to 3. So you start with minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. Then you put in these values. You have minus 7. This is your equation here. So you put minus 7 here, all squared. Minus 7. Wherever you see x, you put minus 7. You evaluate, you get the value, you put it here against your y value. Minus 6, you get 1. Minus 5, you get minus 4. So when you finish, you now do your graph. Again, they will tell you your scale. If a scale is not been given to you, if you use graph paper, you can do it perfectly because the graph papers are already scaled, I think, to 2 by 2 centimeters squared. The graph papers. So you can use a graph paper anyway. But they will give you the scale. Maybe they can say use the y-axis, a scale from this to this, and use the x-axis, a scale from this to this. Then you can solve the problem. So now you come to plot your points on this graph. When you have minus 7, x minus 7, x is minus 7 here. What is the value of y? Y is 8. So x minus 7, y is 8. This is your y values. The y values, they take the vertical axis, and the x values, they take the horizontal axis, or the xy coordinates, they call them Cartesian coordinates. So when you have minus 6 here, the x minus 6 here, what do you have against y? You have 1. So minus 6, y is 1. I've graduated this to be 4. From here to here, 4, 8, 12, 16, 20. So minus 1 would be right here against minus 6. Minus 5, you have minus 4. Minus 5, you have minus 4 at the bottom now. Y is minus 4 and x is minus 5. So you get this smooth graph. But it's a tedious process. You can just see, you've got to put individual values of x, evaluate, you get your y value. It's a tedious process. That is why mathematicians come up with that vertex form formula. Let's go back to it. Now, the vertex form, how we used it, I'm going to illustrate by looking at an example. Let's put it here. You have y equals a into x minus h all squared plus k. It's best explained by solving an example. So with this vertex form, if you look at that graph we watched a couple of minutes ago, if you have a graph like this, because quadratic graphs, they come in two types. We call them parabolas. Parabolas. P-A-R-A-B-O-L-A. So either they go this way, they open up, or you have them, they open at the bottom. But what determines that, we shall come to that when we look at a specific example. Yeah? So looking at this is your h. This value here, this is your h. And from here to here, this is your k value. This is your h value, and this is your k value. From the middle, if you can look at a parabola, they are symmetric. If it goes like this, it has a maximum point here, that is the middle point here, and this part on the left hand side is just a mirror of the part on the right hand side. This is how all parabolas are. They're symmetric. One half is the same as the other half. So this formula will tell you exactly where you get that one half of the quadratic graph. How many minutes? Oh, 10 minutes already. So let me stop this.